What were some early counting devices?
The very earliest counting devices were human hands, with the fingers used as digits. There were limitations to this device, though, especially since each hand only has 5 fingers. To count more items, some cultures assigned even larger counts to other parts of the body. Such counting methods became tedious, so merchants and others who needed to keep track of assorted items turned to nature, using sticks, stones, and bones to count. Eventually, devices called counting boards were developed. At first, the counting boards were simple, usually entailing drawing lines with fingers or a stylus in the sand or dirt.
How do modern cash registers automatically know how much an item costs?
Modern cash registers are actually computers that are able to read a code consisting of a series of vertical bars varying in width. These are called barcodes, or barcode, and represent numbers and other symbols. The barcode is scanned by a laser beam that is sensitive to the reflections from the line along with space thickness and variation. The reader translates the reflected light into digital data that is transferred to a computer for immediate action or storage, usually both resulting in the addition of items purchased and an immediate inventory for the store. For more information about computers, see Math in Computing. But barcodes aren't only for stores. They are also used to check out books from the library, identify hospital patients, and track manufacturing and shipping movements. There are even very small barcodes used in scientific research. For example, to tag and keep track of honeybees.
What is mathematical analysis?
Mathematical analysis is a branch of mathematics that uses the concepts and methods common to the field of calculus. The key to mathematical analysis is the use of infinite processes, in turn. That involves passage to a limit, or, in other words, the basic branch of calculus. For example, a circle's area can be thought of as the limiting value of the areas of regular polygons within the circle. As the number of the polygon sides increase indefinitely. The reason for calculus is simple: it is one of the most powerful and flexible tools not only in mathematics but in virtually every scientific field.
What is the composition of the air?
Meteorologists determine the composition of air by analyzing its various constituents. These are mainly displayed in terms of percent of the atmosphere. The first 40 to 50 miles, 64 to 80 kilometers above the surface contains 99% of the total mass of the Earth's atmosphere. It is generally uniform in composition, except for a high concentration of ozone. Known as the ozone layer, at 12 to 30 miles, 19 to 50 kilometers, in altitude. In the lowest part of the atmosphere, the area in which humans, other animals, and plants live, the most common gases are nitrogen, 78.09%, oxygen, 20.95%, argon, 0.93%, carbon dioxide, 0.03%, and minute traces of such gases as neon, helium, methane, krypton, hydrogen, xenon, and ozone. Water vapor is also present in the lower atmosphere, although variable and at a very low percent. Higher in the atmosphere, the composition and percentages change as the atmosphere thins. For more about percents, see Math Basics.
How do geologists measure the intensity of earthquakes?
Geologists measure the intensity of earthquakes in order to compare and judge potential damage. One of the first standard ways to measure intensity was developed in 1902 by Italian seismologist Giuseppe Mercalli, 1850 to 1914, and is called the Mercalli Intensity Scale. It was later modified and renamed the Modified Mercalli Intensity Scale. The numbers, in Roman numerals from I to 12, represent the subjective measurement of an earthquake's strength based on its effects on local populations and structures. For example, Roman numeral V on the scale represents a quake felt by nearly everyone. With some dishes and windows broken, unstable objects overturned, and disturbances of trees, poles, and other tall objects sometimes noticed. But scientists wanted a more solid, less subjective scale. One of the first scales developed to measure the true magnitude was invented by American seismologist Charles Francis Richter, 1900 to 1985, and German-born seismologist Bino Gutenberg, 1889 to 1960. In 1935, these scientists borrowed the idea of magnitude from astronomers. Stellar brightness is measured by magnitude, defining earthquake magnitude as how fast the ground moved, as measured on a particular seismograph a specific distance from the quake's epicenter. The Richter scale is not a physical scale like a ruler, but rather a mathematical construct. It is not linear, but logarithmic. Thus, an increase in each whole number on the scale represents a tenfold increase in power. Its numbers represent the maximum amplitude of seismic waves that occur 62 miles, 100 kilometers, from the epicenter of an earthquake. Because seismographs are usually not located at this exact interval, the magnitudes are deduced using the arrival of specific waves of energy given off when an earthquake occurs.
What are antiderivatives and antidifferentiation?
An antiderivative is often interpreted as the same as an indefinite integral, but they actually do differ in definition. using the notations above describing the fundamental theorem of the calculus. See box text for definition of the fundamental theorem of the calculus. The function f, x, is an antiderivative of f, x, described as also equal to the integral of f, x. The actual process of finding f, x, from f, x, is called integration or antidifferentiation.
What were some early units used for calculating length?
The earliest length measurements reach back into ancient time, and it is a convoluted history. Some of the earliest measurements of length are the cubit, digit, inch, yard, mile, furlong, and pace. One of the earliest recorded length units is the cubit. It was invented by the Egyptians around 3000 BCE and was represented by the length of a man's arm from his elbow to his extended fingertips. Of course, not every person has the same body proportions, so a cubit could be off by a few inches. This was something the more precision-oriented Egyptians fixed by developing a standard royal cubit. This was maintained on a black granite rod accessible to all, enabling the citizenry to make their own measuring rods fit the royal standard. The Egyptian cubit was not the only one. By 1700 BCE the Babylonians had changed the measurement of a cubit, making it slightly longer. In our measurement standards today, the Egyptian cubit would be equal to 524 millimeters, 20.63 inches. And the Babylonian cubit, cubit 2, would be equal to 530 millimeters, 20.87 inches. The metric unit millimeters is used here, as it is an easier way to see the difference between these two cubits. As the name implies, a digit was measured by the width of a person's middle finger and was considered the smallest basic unit of length. The Egyptians divided the digit into other units. For example, 28 digits equaled a cubit, 4 digits equaled a palm, and 5 digits equaled a hand. They further divided 3 palms, or 12 digits, into a small span, 14 digits, or a half cubit, into a large span, and 24 digits into a small cubit. To get smaller measurements than a digit, the Egyptians used fractions. Over time, the measurement of an inch was all over the measurement map. For example, 1 inch was once defined as the distance from the tip to the first joint on a man's finger. The ancient civilization of the Harappan in the Punjab used the Indus inch. Based on ruler markings found at excavation sites, it measured, in modern terms, about 1.32 inches, 3.35 centimeters, see below for more about the Harappan. The inch was defined as 1/36 of King Henry I of England's arm in the 11th century. And by the 14th century, King Edward II of England ruled that 1 inch equaled 3 grains of barley corn placed end to end lengthwise. See box on p46 for more about both kings. Longer measurements were often measured by such units as yards, furlongs, and miles in Europe. At first, the yard was the length of a man's belt, also called a girdle. The yard became more standard for a while. When it was determined to be the distance from King Henry I's nose to the thumb of his outstretched arm. The term mile is derived from the Roman mille passus, or 1,000 double steps, also called paces. The mile was determined by measuring 1,000 double steps, with each double step by a Roman soldier measuring 5 feet. Thus, 1,000 double steps equaled a mile, or 5,000 feet, 1,524 meters. The current measurement of feet in a mile came in 1595, when, during the reign of England's Queen Elizabeth I, it was agreed that 5,280 feet, 1,609 meters, would equal 1 mile. This was mainly chosen because of the popularity of the furlong. 8 furlongs equaled 5,280 feet. Finally, the pace was once attached to the Roman mile, see above. Today, a pace is a general measurement, defined as the length of one average step by an adult human, or about 2.5 to 3 feet, 0.76 to 0.19 meters.
Why has the combination of mathematical analysis methods and computers been so important?
The combination of mathematical analysis and computers has been a strong alliance, especially with regard to engineering, technology, and the sciences. In the past few decades, researchers have used this combination to help predict the weather, describe in great detail nuclear fusion in the Sun, understand the movement of space bodies around the solar system, orbital mechanics, and the flow of water in underground aquifers, fluid dynamics. There are also the studies of chaos, the unpredictable behavior of nonlinear systems, and quantum mechanics, or the physics of very small particles, both of which entail the use of applied mathematics and computers. In addition, in engineering and almost all technology, the mathematical analysis computer combination has helped create structures that surround us every day. This includes familiar modes of transportation and communication, from plans for airplanes and bridge construction to designing fiber optic cables and cell phone towers. It also includes how engineers design control systems, which are used in such diverse areas as robotics, aerospace engineering, and biomedical research.
How can people calculate their age and weight on other planets?
It is certainly possible to find a person's age and weight on another planet without actually having to travel there. To figure out weight, one just needs to know the gravitational pull on another planet, moon, or other space body. For example, based on the chart below, if a person weighed 100 pounds on Earth, he or she would weigh 38 pounds on Mercury, 100 x 0.38. A person's age on Earth depends on how many times the planet has orbited the Sun during his or her lifetime. For example, a person 30 years old has traveled around our star 30 times. In order to work out how old a person is on another planet, the person's age has to be divided by the period of revolution, in terms of Earth years. Thus, if the same 30 Earth-year-old person lived on Saturn, he or she would be just over 1 Saturn-year-old, 30/29.5 equals 1.02 Saturn years. On Mercury, the person would be 124.5 Mercury years old, 30/0.241 equals 124.5 Mercury years.
What mathematical concept was featured in the movie The Andromeda Strain?
The concept of exponential growth, also known as geometric growth, provided the tension in this movie and the book on which it was based. The basic premise was that microscopic organisms had been inadvertently brought to Earth from outer space by a returning satellite. Once on Earth, they reproduced exponentially, doubling in number every 20 minutes. Very quickly, they spread over the entire planet, killing nearly everyone. And no, we won't give away the ending.
How is the sales tax calculated at the checkout?
Take, for instance, a purchase of a $100 ring in New York City. A place with a sales tax rate of 8.265%. Multiply $100 times 8.265%, or $100 x 0.08265 equals $8.265, which rounds up to $8.27 for sales tax. The merchant would then charge the customer a total of $100 plus $8.27 equals $108.27. If the same $100 ring was purchased in Florida, the sales tax would be $100 x 6%. Or $100 x 0.06 equals $6, with a total purchase price of $106. Of course, not every purchase will be as straightforward as this, since some cities can also add local taxes and or surcharges and fees to the bill.
What is a common example of mathematical modeling?
One of the most common examples of a mathematical model has to do with the growth of populations, human, animal, or otherwise. In the sciences, this type of mathematical modeling often leads to intelligent hypotheses about the future and past of a population, from a possible population explosion to even an extinction. For more information about the use of mathematical modeling in the sciences, see Math in the Natural Sciences.
Who developed the two alternatives to Euclidean geometry?
Hyperbolic geometry was first announced by Russian mathematician Nikolai Ivanovich Lobachevsky, 1792–1856, also seen as Lobachevsky. In 1826, he challenged Euclid's fifth postulate that one and only one line parallel to a given line can be drawn through a fixed point external to the line. Instead, he developed a self-consistent system of geometry in which the flawed postulate was replaced by one allowing more than one parallel through the fixed point. This idea was already developed independently by Hungarian János, or Johann Bolyai, 1802–1860, in 1823, after several attempts to prove the Euclidean parallel postulate. He developed his system by assuming that a geometry could be constructed without the parallel postulate. And German mathematician, physicist, and astronomer Carl Friedrich Gauss, 1777–1855, also seen as Johann Carl or Carl Friedrich Gauss, in 1816. But, as often happens in science and mathematics, the person who publishes an idea first gets most of the credit. This time, Lobachevsky was the first to publish.
Why are mathematicians so interested in transcendental numbers?
Transcendental numbers are those that are not the root of any integer polynomial, or that are not an algebraic number of any degree. Thus, all transcendental numbers are irrational. Rational numbers are algebraic numbers of degree 1. The importance of such numbers translates through more than 2 millennia of history. For example, they provided the first proof that circle squaring was insoluble, which is one of the geometric problems that has baffled mathematicians throughout antiquity. Rings are usually named after one or more of their investigators, but such a practice usually makes understanding the properties of the various associated rings difficult for anyone other than the mathematician working on the ring.
What is an ion?
Scientists know that atoms can gain or lose electrons, thus acquiring a negative or positive electrical charge, determined by the number of protons minus the number of electrons. For example, if there are 4 protons and 6 electrons, the net charge is -2, often called the valence. An ion is an atom or group of atoms that takes on the net electric charge, and can be positive, cation, or negative, anion. Based on the mathematics of losing or gaining electrons, ions can be formed or destroyed. This is one example of where math comes in handy in chemistry.
What is Russell's paradox?
Russell's paradox is one of the most famous of the set theory paradoxes. It first appears when studying the naive set theory. In this case, R is the set of all sets that are not members of themselves. From there, R is neither a member of itself nor not a member of itself. The paradox sets becomes evident when one tries to reason how a set appears to be a member of itself if and only if it is not a member of itself. Discovered by Welsh mathematician and logician Bertrand Arthur William Russell. 1872 to 1970, in 1901, the paradox sparked a great deal of work and controversy in logic, set theory, and especially in philosophy and foundations of mathematics. The reason why it became so important was its effect on mathematics. It created problems for those who based mathematics on logic. And it also indicated that something was wrong with George Cantor's intuitive set theory. For more about Russell and the paradox, see History of Mathematics.
What are some details of Jean-Baptiste Fourier's life?
The accomplishments of French mathematician and physicist Baron Jean-Baptiste Joseph Fourier. 1768 to 1830, prove that not all famous mathematicians did just math. Fourier was a teacher, became involved in the messy French Revolution, and was arrested for his views and imprisoned in 1794. For a time, he even feared the guillotine, but political changes resulted in Fourier being freed. By 1798 Fourier joined Napoleon's army in its invasion of Egypt as a scientific advisor. After Napoleon lost the Battle of the Nile to Nelson and was confined to Malta, Fourier continued his work in Egypt, establishing educational facilities there and carrying out archaeological explorations. Back in France with Napoleon in 1801, he supervised the draining of the swamps of Bourgoin and the construction of a highway from Grenoble to Turin. He also spent time writing Description of Egypt, a book that Napoleon edited, and included some historical rewrites. By the second edition of the book, Napoleon himself would be completely edited out of the text. As if he wasn't busy enough, during this time Fourier wrote his now famous 1807 paper on the propagation of heat in solid bodies, a mathematical work on the theory of heat that presented one of his major contributions, the Fourier series. But it was an uphill battle to get approval from his peers. In 1811 he submitted his 1807 ideas for a mathematics prize, along with additional work on the cooling of infinite solids and on terrestrial and radiant heat. Only one other entry was received, making Fourier's work the obvious winner. Finally, by 1822, he published his 1811 essay, making the techniques of Fourier analysis available to everyone. To this day, the functions that he worked out have a multitude of applications in engineering, science, and mathematics.
Who was François Vite?
French mathematician François Vite, or Franciscus Vita, 1540 to 1603, is often called the founder of modern algebra. He introduced the use of letters as algebraic symbols, although Descartes see below introduced the convention of letters at the end of the alphabet X, Y, for unknowns and letters at the beginning of the alphabet A, B, for knowns, and connected algebra with geometry and trigonometry. He also included trigonometric tables in his Canon Mathematicus. 1571, along with the theory behind their construction. This book was originally meant to be a mathematical introduction to his unpublished astronomical treatise, Ad Harmonicon Coelest. For more about Veit, see Algebra and Geometry and Trigonometry.
What movies had mathematics as their primary focus?
The following three movies were either about mathematicians or had a dominant mathematical theme. A Beautiful Mind, 2001, based on the book by Sylvia Nassar, also see above. This is Hollywood's version of John Nash's rise, descent into mental illness, and eventual redemption. Directed by Ron Howard, it stars Russell Crowe and Ed Harris. Pi, 1998, this dark, low-budget, black-and-white film is about a mathematician's obsessive search for patterns in everything. While everyone from Wall Street investors to religious fundamentalists want to find and exploit him. Directed by Darren Aronofsky, it stars Sean Gullett and Mark Margolis. Infinity, 1996, this movie about the early life of brilliant and eccentric Nobel Prize-winning physicist Richard Feynman. 1918 to 1988, is both a tribute to the scientist and a whimsical romance. Directed by Matthew Broderick, it stars Matthew Broderick and Patricia Arquette.
Who built the first known adding machine?
No one knows who built the first adding machine. Although many historians believe it was German mathematician Wilhelm Schickard. 1592 to 1635, who first invented a mechanical calculator in 1623 based on Napier's bones, see above. Schickard and his family perished from the bubonic plague. It was not until the mid-20th century that his notes and letters were discovered. They showed diagrams of how to construct his machine. Schickard apparently built two prototypes. One was destroyed in a fire and the other one's location is unknown, if it survived at all. His device, which he called the calculating clock, was able to add and subtract up to 6-digit numbers using a mechanism of gears and wheels. But not all historians credit Schickard. Some believe that there was an even earlier attempt at mechanical computing by Leonardo da Vinci, who also apparently designed an adding machine. Some of his notes were found in the National Museum of Spain in 1967 and describe a machine bearing a certain resemblance to Pascal's machine, see below.
What is a fallacy?
A fallacy is an incorrect result in this case. One arrived at through misleading reasoning when examining a logical argument. One of the more common fallacies in logic is believing incorrectly that if P implies Q is true, then Q implies P is also true. The idea of such invalid arguments was well known in the past, with Greek mathematician Aristotle's syllogisms. An argument was valid if it adhered to all the laws; to be false, it only needed to break one law. Euclid, another Greek mathematician, was known to have written an entire book on fallacies in geometry, but the book has since been lost.
What is the scale of a map?
Most travel, street, or highway maps show a measurement scale, usually in terms of miles and kilometers. To determine a straight line, horizontal, distance on a map, take a piece of paper and mark the origin and destination as tick marks on the paper. Then measure the distance between the tick marks based on the map scale to find the distance in miles or kilometers. Topological maps also have scales, but in this case the scale is a ratio representing the measure on a map to some number of the actual units of measure on the Earth's surface. For example, a map with a scale of 1:25,000 means that 1 inch on the map is equal to 25,000 inches on the ground. Because both numbers have the same units, it can also be interpreted as any unit measure. For example, the same map could also be interpreted as 1 centimeter equals 25,000 centimeters on the ground, or 1 meter equals 25,000 meters, and so on. For those who prefer to measure in miles and kilometers, most topographic maps also offer a graphic scale in the legend. For more about scales, see Math in Engineering.
What is a rate?
The rate is often used in measurement. It is defined as the comparison by division, similar to a ratio. For example, when measuring miles or kilometers per hour in your car, the rate equates the pairs of miles, kilometers, with hours. The translation for a rate of 65 miles per hour is that for each hour, one will travel 65 miles as long as the speed remains the same for that hour.
An even easier way is to what is the chi-square test?
The chi-square test is a way to determine the odds for or against a given deviation from the expected statistical distribution. This somewhat complex statistical test computes the probability that there is no major difference between the expected frequency of an event with the observed frequency of that event, and especially to determine if the set of responses is significantly different from an expected set of responses only because of chance. There are even various ways to perform this type of test, such as the Pearson's chi-square test. Square the numbers first. Note, taking the square root of the variance gives the standard deviation. For example, take the numbers 3, 5, 8, and 9, with a mean of 6.25, the sum of the numbers divided by the total number of numbers. To calculate the variance, determine the deviation of each number from 6.25, 3.25, 1.25, 1.75, 2.75. Square each deviation: 10.5625, 1.5625, 3.0625, 7.5625. Then take the average 22.75/4 equals 5.6875, which is the variance. An easier way to calculate the variance is to square all the numbers first. 9, 25, 64, 81, and determine the mean. 9 plus 25 plus 64 plus 81 divided by 4 equals 44.75. Then subtract the square of the first mean. 6.252 equals 39.0625, or 44.75. 39.0625 equals 5.6875.
How does one determine the distance and amount of time a trip will take?
There are several ways to determine the distance and amount of time a trip will take. For example, if the traveler knows that his or her car travels 20 miles for every gallon of gas in the tank, he or she could represent the total number of miles it is possible to drive based on how much gas is put into the tank. This can be expressed as 20g, in which g stands for the number of gallons in the tank. For example, if someone bought 10 gallons of gas to reach a destination, 10 gallons x 20 miles/gallon, the traveler can go about 200 miles. The gallons in the top and bottom of the equation cancel each other out, leaving miles. Another example involves cars and mileage. If the traveler drives down a highway at a steady rate of 65 miles per hour, the driver can determine how long it will take to get to a destination, especially if he or she knows how many miles it is to that destination. The equation is mileage divided by 65 miles per hour, m/65. For example, if the traveler is going 650 miles, the 650 miles / 65 miles per hour equals 10 hours, the miles in the top and bottom of the equation cancel each other out, leaving hours.
Who developed analytic geometry?
Analytic geometry began when French philosopher, mathematician, and scientist René Descartes, 1596–1650, in Latin. René Descartes' published a work explaining how to use coordinates for finding points in space. He was the first to make a graph and presented a geometric interpretation of a mathematical function. This marked a step toward what is now known as Cartesian coordinates, a term derived from Descartes' Latin name. Around the same time, an independently French mathematician Pierre de Fermat (1601–1665) also did much to establish the ideas of coordinate geometry. But, unlike Descartes, Fermat did not publish his work. Both Descartes' and Fermat's ideas would lead to modern Cartesian coordinates. For more about Descartes and Fermat, see History of Mathematics.
How are angles measured?
Angles are measured in two major ways, degrees and radians. Similar to degrees on a temperature scale. Degrees in mathematics, especially when discussing angles, are usually denoted by the symbol degree. They are divided into 60 arc minutes, and arc minutes are divided into 60 arc seconds. The multiples of 60 are thought to be connected to the Babylonian sexagesimal number system. 1 based on the number 60, in which the year was composed of 360 days, or 12 months at 30 days each. If the vertex of an angle and one side are fixed and the other side is rotated about the vertex, it sweeps out a circle of 360 degrees with each complete rotation. Said another way, a full rotation is 360 degrees. Radians, denoted as rad, are real numbers represented as an angle. They are the central angle of a circle determined by two radii and an arc joining them. In degrees, a radian is about 57.29578 degrees or 180/pi degrees, because a semicircle contains pi radians. For example, pi/6 is equal to a 30-degree angle, because a straight angle is pi radians. Or 180 degrees, if you divide 180 by 6, or pi/6, it is equal to 30 degrees. Radians are most often used in probability and statistics, or calculus, especially to obtain the derivative of trigonometric functions.
What early mathematicians are thought to be responsible for originating the use of algebraic methods and ideas?
To some scholars, Greek, Hellenic, mathematician Diophantus, c. 210 c. 290, is considered the father of algebra, as he developed his own algebraic notation. His words were noted and preserved by the Arabs. The translation of his words into Latin in the 16th century led to many algebraic advances. In more modern times, French mathematician François Vide, 1540–1603, also known by the Latin name Franciscus Vitae, is often credited as the founder of modern algebra. For more information about Diophantus and Vitae, see below and History of Mathematics.
What is combinatorics?
Combinatorics is a branch of mathematics overall, called combinatorial mathematics that studies the enumeration, combination, and permutation of sets and the mathematical relations that involve these properties. Defined as, enumeration sets can be identified by the enumeration of their elements. In other words, determining, or counting, the set of all solutions to a given problem. Combination is how to count the many different ways elements from a given set can be combined. For example, the two combinations of the four set A, B, C. D are A, B, A, C, A, D, B, C, B, D, C, D. Permutation is the rearrangement of elements of a set into a particular order, often in a one-to-one correspondence. The number of permutations of a particularly sized set with n members is written as the factorial n. For example, a set with 4 members would have 4 in first place to 1 in the last place. This would equal 4x3 x2 x1 equals 4, or 24, permutations of 4 members. For more information about factorials, see algebra.
What is the connection between counting and mathematics?
Although early counting is usually not considered to be mathematics, mathematics began with counting. Ancient peoples apparently used counting to keep track of sundry items, such as animals or lunar and solar movements. But it was only when agriculture, business, and industry began that the true development of mathematics became a necessity.
What is a quantifier in predicate calculus?
A sentence or many sentences containing a variable, such as x, can be made into true or false propositions simply by using a quantifier. The quantifier actually assigns a truth value to the sentence, depending on the set of values allowed for that variable. There are two major quantifiers, the existential and universal quantifiers, which are represented by the logical operator symbols of 3 and v, respectively. Although there are also more exotic types of logic that use different quantifiers.
What is a Fourier series?
The idea for the Fourier series was developed by French mathematician and physicist Baron Jean-Baptiste Joseph Fourier, 1768 to 1830, as an alternate method of expressing a function by the expansion of the function. A Fourier series is actually a specific type of infinite mathematical series that involves trigonomic functions. More simply put, it is essentially an infinite sum of sine waves. The Fourier series is used in applied mathematics. In engineering and physics, it is used to split up a periodic, or continuous, function into a group of simpler terms, in electronics. It is used to express the periodic function seen in waveforms of communication signals.
How are points determined in a real estate transaction?
Hen buying a home through a real estate group or bank. Points may be paid by the borrower at the time a loan is made. This is usually to get a lower interest rate. Because the lender often offers certain rate/point combinations that may help the homeowner save money. Actually, points usually refer to the commission charged by the mortgage broker or the loan fee charged by the lender when the loan is made. Points can be also negative, in which case they are called rebates from the lender to the borrower and are often used by borrowers to defray other settlement costs. In general, each point is 1% of the loan amount. For instance, 3 points would be equal to 3% of the total loan amount. There is no set number of points offered by a lender, as it is not controlled by any laws. For example, on a $100,000 loan, 1 point is equal to $1,000, 10 points is equal to $10. 000. A homeowner looking for a loan should try to find a mortgage broker or lender that charges fewer points. Some financial institutions might even be willing to negotiate for lower points. But beware of lenders offering no or 0 points, because they usually charge much higher interest rates than those offering loans with points. Although it is a matter of mathematics and a person's budget, there are some very general guidelines when choosing a mortgage. Low-rate, high-point loans are usually used by borrowers who can meet the down payment cash requirement and either want to stay in a house a long time or want to reduce their monthly mortgage payments. High-rate, low-point combinations are for borrowers who don't expect to be in their houses very long, or who are short on cash.
Who was Adrien Marie Legendre?
Adrien Marie Legendre, 1752–1833, was a brilliant French mathematician and physicist. He is known for his studies of ellipsoids, leading to what we now call the Legendre functions, and celestial mechanics, and he worked on the orbits of comets. In 1787 he helped measure Earth using a triangulation survey between the Paris and Greenwich observatories. In 1794 Legendre published Elements de Géométrie, an elementary text on geometry that would essentially replace Euclid's Elements and would remain the leading text on the topic for close to a century. Finally, Legendre also had an important connection to measurement. In 1791 he was appointed to the Committee of the Académie des Sciences, which was assigned the task of standardizing weights and measures.
What are some examples of paradoxes throughout history?
The oldest paradoxes may be from the Greek Epimenides the Cretan. Lived sometime during the 6th century BCE, who stated, "All Cretans are liars." If this statement is true and any other culture you would care to put in the Cretans' place, then the implication is that the statement is a lie. This is also called the liar's paradox. The number of paradoxes has continued almost ad infinitum since then. Some of the more popular ones include those listed as Zeno's paradoxes. They are named after Greek philosopher Zeno of Elea, c. 490–c. 425 BCE. A disciple of the philosopher Parmenides, who believed that reality was an absolute, unchanging whole and thus, that many things we take for granted, such as motion, were simply illusions. In order to defend his master's highly debated philosophy, Zeno developed his paradoxes. Most of Zeno's paradoxes are still highly debated by modern mathematicians and philosophers. Thus proving another paradox: nothing truly changes throughout history, or does it?
What are the surface area, lateral area, and volume of a sphere?
A sphere is a set of points equidistant from a central point. A center, a sphere in 2 dimensions, is a circle.
What is an abacus?
An abacus, the plural being either abacuses or abaci, is one of the earliest counting devices. The term comes from a Latin word with origins in the Greek words abax or abakon, meaning tablet or table. These words probably originated with the Semitic word abq, or sand. The device is originally made from wood but now usually including plastic perform arithmetic functions by manually sliding counters, usually beads or discs, on rods or wires. Contrary to popular belief, abaci were not truly calculators in the sense of the word today. They were used only as mechanical aids for counting. The calculations were done inside the user's head, with the abacus helping the person keep track of sums, subtractions, and carrying and borrowing numbers. For more about carrying and borrowing in arithmetic, see Math Basics.
How is mathematics used in chemical engineering?
Mathematics is used a great deal in chemical engineering, especially since chemical engineers design materials and the processes by which those materials are made. To solve chemical problems, many types of mathematics are used, not least of which is calculus, including partial differential equations. Even simple calculations, such as working on chemical formulas and equations, involve mathematics. For more information about chemical formulas and equations, see Math in the Physical Sciences. Traditionally, chemical engineers worked in the petroleum and large-scale chemical industries. More recently, they have spread out to the pharmaceutical, foodstuff, polymer and material, microelectronics, and biotechnology industries. Using mathematics, they are involved in such studies as thermodynamics, chemical reaction processes, and process dynamics, design and control. They help to develop new chemical products and processes, test processing equipment and instrumentation, gather data, and monitor quality. Chemical engineers also build mathematical models and analyze the results, mostly to help understand the performance of a process. In fact, the solution to a math problem is often in the understanding of the behavior of the process described by the mathematics, rather than the specific numerical result.
How did the first standard metric measurements evolve over time?
The first standard metric units were developed by 1799, the meter was defined as 1/10,000,000th of the distance from the equator to the North Pole. The liter was defined as the volume of 1 cubic decimeter, and the kilogram was the weight of a liter of pure water. The standards metamorphosed over the years. For example, the first physical standard meter was in the form of a bar defined as a meter in length. By 1889 the International Bureau of Weights and Measures, BIPM, or Bureau International des Poids et Mesures, replaced the original meter bar. The new bar not only became a standard in France, but copies of the newest bar were distributed to the 17 countries that signed the Convention of the Meter, Convention du Meter, in Paris in 1875. The accepted distance became 2 lines marked on a bar measuring 2 cm by 2 cm in cross-section and slightly longer than 1 meter. The bar itself was composed of 90% platinum and 10% iridium. But it was only a standard meter when it was at the temperature of melting ice. By 1960 the BIPM decided to make a more accurate standard, mostly. This was done to satisfy the scientific community's need for precision. The new standard meter was based on the wavelength of light emitted by the krypton 86 atom, or 1,650,763.73 wavelengths of the atom's orange-red line in a vacuum. An even more precise measurement of the meter came about in 1983, when it became defined as the distance light travels in a vacuum in 1/299,792,458 second. This is the currently accepted standard.
Can there be more than one type of number?
Yes, numbers can be classified as more than one type, and it's not always easy to keep them straight. The following lists some ways to better understand the plethora of number types. A rational number is not always an integer. 4/1 is an integer, but 2/3 is not. But an integer is always a rational number because it can be represented by a fraction by putting the integer over 1, or /1, such as 2/1 or 234/1. A number can either be rational or irrational, but not both. The number for pi, 3.141592, is irrational, the decimal does not repeat, and real 0.
What is a point spread?
A point spread is the predicted scoring difference between a game's two opponents. It is used by bookmakers to equalize two teams for betting purposes. For example, if a person chooses the team that is favored, the gambler has to win by more than the point spread in order to get credit for a correct pick. If the underdog team is chosen, the bettor must lose by less than the spread number in order to get credit for a correct pick. If a point spread is listed as off, this means there is no official point spread for the game. For example, if a person picks Army to win, and the team is favored to beat Navy by 5 points, called a spread of 5 points, Army must win the game by 6 or more points in order for the bettor to win. If Army wins by exactly 5 points, the game is called a push, and no one wins.
What does borrow mean in subtraction?
As with carry in addition. To borrow in subtraction means to take amounts from one number and assign them to the next. In this procedure, the 10 is borrowed from the next highest digit column in order to obtain a positive difference in the nearby column. When you subtract the same columns, starting in the right-hand column, the 4 is too small to subtract from 7, therefore, you need to borrow 10 from the column to the left, boosting the number 4 to 14. The column to the left then loses 10, and 2 is left. Again, the 2 is too small to subtract from 6, so 10 is borrowed from the next column to the left, boosting the number 2 to 12. The last number to the left is dropped down by 10, giving 11, the 5 is subtracted from the 11, resulting in 6 in that column.
What was the Principia Mathematica?
In 1910 the first volume of the Principia Mathematica was published by Welsh mathematician and logician Bertrand Arthur William Russell. 1872 to 1970, and English mathematician and philosopher Alfred North Whitehead, 1861 to 1947. This book was an attempt to put mathematics on a logical foundation, developing logic theory as a basis for mathematics. It gave detailed derivations of many major theorems in set theory, examined finite and transfinite arithmetic, and presented elementary measure theory. The two mathematicians published 3 volumes, but the fourth, on geometry, was never completed. On their own, both men did a great deal to advance mathematics, too. Russell discovered the Russell paradox, see below. Introduced the theory of types, and popularized first-order predicate calculus. Russell's logic consisted of 2 main ideas, that all mathematical truths can be translated into logical truths, or that the vocabulary of mathematics constitutes a proper subset of the vocabulary of logic, and that all mathematical proofs can be recast as logical proofs, or that the theorems of mathematics constitute a proper subset logical theorems. Whitehead excelled not only in mathematics and logic but also in the philosophy of science and study of metaphysics. In mathematics, he extended the known range of algebraic procedures, and he was a prolific writer. In philosophy, he criticized the traditional theories for their lack of integrating the direct relationship between matter, space, and time. Thus, he created a vocabulary of his own design, which he called the philosophy of organism.
What are some interesting facts about the Julian and Gregorian calendars?
An interesting fact about the Julian calendar is that it designates every 4th year as a leap year. A practice that was first introduced by King Ptolemy III of Egypt in 238 BCE. A quirk about the Gregorian calendar is that the longest time between 2 leap years is 8 years. The last time such a stretch was seen was between 1896 and 1904. It will happen again between 2096 and 2104.
What are the odds when playing craps?
Craps is probably the most popular game of chance in the world. It is also illegal to play in many places. But it has a long history. It was played in ancient Greece and Rome and was even a mainstay of some old 1930s and 40s movies. Craps can be played using a wall and a pair of dice. It is a popular casino game in places such as Las Vegas and even on the internet, with betting on craps involving a complex equation. Its popularity no doubt comes from its simplicity. In craps, a player throws 2 dice, their number, roll, is the total of the dots on the top faces of the dice. If the initial roll is a 7 or 11, called a natural, the player wins. If the number 2, 3, or 12 comes up called craps, the player loses, but keeps the dice. If the sum of the dice adds up to the number 4, 5, 6, 8, 9, or 10, that number becomes the thrower's point. The player then continues to shoot until he or she throws the point number again, in which case the gambler wins and retains the dice. But if the player shoots a sum of 7 before he or she can roll the point value, he or she loses and gives the dice to the next player. Craps is truly a game of chance, with the probability mathematics of craps fairly straightforward. For example, take the probability of winning on a roll-by-roll basis, in which p equals n, is the probability of rolling a point n. The resulting numbers show that the probability of winning is 244/495. Or the shooter wins about 49.2929% of the time.
What is predicate calculus?
Predicate calculus, also called first-order logic, functional calculus, or quantification theory, is a theory in symbolic logic that uses statements such as there exists an object such that, or for all objects, it is the case that. It is a much more solid theory than propositional calculus. Taking the interrelationship between sentences much farther. But it is weaker than certain branches of mathematics, such as arithmetic and set theory.
Who invented the symbol for zero?
Although the Babylonians determined there to be an empty space in their numbers, they did not have a symbol for zero. Archaeologists believe that a crude symbol for zero was invented either in Indochina or India around the 7th century and by the Mayans independently about 100 years earlier.